This is a great crowd. Thanks very much for coming. I'm a director of Exactal. I'm also a QS by profession. Had about a 30-year career in quantity surveying before doing this, and I must say I'm greatly enjoying this current stage of being involved in actively changing the industry, and BIM is certainly an agent for change, and it's a very powerful agent for change, I think, as we'll see tonight. A little bit of an overview of Exactal, the company. It was established in 2003 in Brisbane, specifically to tie CAD data into estimating and scheduling workbooks so that people could actually move on from paper. Over the 10 years, it's been under continuous development and continues to be, because it's sort of paralleled a lot of changes in the industry and technology changes that continue to happen. And we've sort of stayed ahead of that to the extent that we now have Costix users in 60 countries, in fact, over 60 countries worldwide, and 7 offices in 5 countries, 2 of which are in the UK, 1 in London, 1 in Newcastle. The key product that we have is Costix, and that's what we're sort of here to talk about tonight. It's estimating software, and as I say, it's CAD and BIM enabled, and it ties the CAD and BIM data into your workbooks. So key aspects of it are, in comparison to other products around, is the universal application of 2D and 3D. If you want to just do on-screen measurement from 2D drawings, that's fine, you can do that, or you can get involved in proper data extraction from BIM models as well. The fact that it live links the quantities into the workbook, so, the quantities that we take here are actually live linked into our workbooks, which means that if you update the quantities, the workbook updates too, and that live linking sort of helps to avoid scope creep, those sorts of things. Particularly the revisioning capability, the fact that when the drawings change, because we've linked into the CAD data or the BIM data, we can actually show you where the changes occurred and update the quantities. So again, that sort of elimination of scope creep is a very important aspect. So essentially that's what the product is, and the reason people are buying it is for those sorts of key reasons. Now, because tonight we're going to be talking about BIM, and it's always important to make sure that everyone's on the same page as to what exactly BIM is. So any kind of drafting, whether it's 2D or 3D, is simply lines on paper or on a computer screen. So up here, sorry, did it again. To denote a door, we simply draw a straight line for the door leaf, curved line for the swing arc. We all know it's a door, but it's just lines. BIM is object-based data modelling. The designer literally builds a model out of a kit of parts. They have a library in their computer. That library is database driven. It consists of objects. If they want to put a door in a building, they go to their library, select a door object, place it in the building. The door knows that it's a door. It carries properties relating to the door. And importantly, it also carries properties about its interrelationship with other objects. So when it's placed into a wall, the wall knows that there's a door, an opening gets formed. And it's that interrelationship of the objects that provides a lot of the power of BIM modelling. And it's also the fact that you have that data that you're then able to share amongst the team and to carry out various analyses of the model. So the differentiator is BIM is object-based data modelling. It's not 3D drawing. Building information modelling, I mean, BIM is an acronym. A BIM model is not really, it's a building information model. Building information modelling, it's like the distinction between a cost plan and cost planning. Cost planning is the process that you go through, as opposed to a cost plan that's a snapshot at a particular point in time. Because of that data model, you have the ability to analyse the model, run what-if scenarios, test the design, test various options, and it can all be done very quickly and readily. The information that populates the model obviously informs the analyses that you do, so the better the information in the model, the more reliable the outcomes are that you're going to achieve. But simply, it's the fact that you can optimise the design by simply running any number of analyses to test the design and basically validate it virtually before you actually press the go button. So that's what building information modelling is. So why is it of interest to quantity surveyors and estimators? Well, because improving cost outcomes is obviously a major performance metric for any project. That speedy data extraction enables you to basically process more data more quickly, so you can provide better advice. So you can feed back to the design team. You can do it much more quickly, so that traditional lag where you used to wait to receive drawings, you'd measure them up, do your analysis. By the time you get back to them, they've already moved on. they're on a different page. You can virtually talk to them in real time. It's not always important to have absolute figures. Often you're just running comparisons, and the fact that you can run comparative options almost straight away and feedback means that you can really actively collaborate and contribute to the development of the design in a way that you just haven't been able to do before. So that's why it's important to get on board with 5D BIM. Now, we were all aware of the Cabinet Office mandate for BIM adoption by 2016. There's been a lot of talk about it, and I guess the question is, what does it actually mean? So this chart, the Bew-Richards chart, talks about level 2. It's probably hard to see the colour, but they've sort of mandated to try and achieve level 2 maturity. I mean, the chart here simply you can see developing from CAD, 2D, 3D, drafting through BIM, ultimately to iBIM. They're looking for level 2. So the question is, what actually is level 2? Well, you can see the definition there. A managed 3D environment using separate discipline BIM tools. So basically moving from CAD drafting, whether it's 2D or 3D, into active BIM modelling in a shared environment. Interesting though, the process and deliverables that are also defined as part of that level 2 has 2D with a very important function right there in the middle. So you're talking about a suite of documents, if you like. It's not just that there'll be a model and you'll have to work off that model. There'll be a set of information, and the information will contain a variety of different data types and sources. And importantly, it'll include a 3D model and it'll include 2D PDFs as well. And not necessarily PDFs, they can be in CAD format. The AEC UK BIM Protocol modelling methodology, as you see it there, basically sets this out with quite a nice chart. So you have your 3D model, you cut views from the model, so essentially plans, elevations, sections are created by cutting views from the model. Those views get put on sheets, they get issued. So long as those sheets contain that linkage back to the model, then all the time the model is developing and being worked on, you maintain that linkage so you have the information flow. If you break that linkage by putting output into CAD and then adding information in CAD separately, then of course you've broken the linkage, so you're not getting the benefit of the single source of information being the BIM model. So really this is more like the level 1 that we were talking about. This is level 2 up here. So the AEC protocol also addresses this 3D, 2D nexus. So it actually says it'll be dictated at which point 3D geometry ceases and 2D detailing is utilised. So this is important because you can't model everything in 3D. And certainly from communication purposes, it's sometimes better to put things in 2D. I mean, if you're trying to do a furniture arrangement, it's a lot easier to work on a plan than it is to try and sort of model it in 3D. So working from there, there will be a point where it's simply better and easier to put 2D detailing in. The other important aspect of this is that it reduces the model size, because too much information in the model just makes the model unwieldy. It's cluttered and the file size is too big and people downstream can't handle it. So that introduces an important concept known as level of development, which is defined by the American Institute of Architects, but actually has pretty much been adopted now. It's not the level of detail, it's not drawing detail, it's the reliability of the data. In other words, it's how far the design has actually been resolved, what decisions have actually been made that you can rely on. So simply LOD 100, you know that you're going to put a chair, you don't know what sort of chair, you don't know what it's going to be like, that decision won't be made for another 18 months. So make sure you allow for a chair, but at this stage we don't know what it's going to be. As you go through 200, 300, 400, and you can see it's the data being added that relates to the resolution of the design. It's not the detailing. Because what will happen is that at the very earliest stage of a model, there will be a lot of detailed rendering of things like chairs and furniture and all sorts of things. They will look very detailed, but the decisions have not been made yet, so you can't necessarily rely on them. This is as opposed to the level of detail, which talks about the resolution. And the BIM protocol has actually used a different name. They've called it graded component creation because LOD becomes too confusing. Do you mean level of development, level of detail? And so, as you can see, G3 is fully rendered. What you could well end up with is that you get a G3 rendering back at LOD 100. So as I say, it's the very earliest concept stage, but you've got a fully detailed chair. And the issue with that, as I say, it'll make the model too big, it'll clutter the model, but also it's deceptive because you'll assume that decision's been made and actually it hasn't. So a BIM execution plan will actually, or can, include a table that actually lists out levels of development for the various elements in the model. So the way that this might look is, you can see here where we've got the level of development here from 100 through to 500, similarly level of detail. What will happen with your earlier models is that you'll probably have a lot more detail than you do level of development. So BIM models look really impressive because they look so resolved, but they're not. You know, they're very early in the stage. What you're actually looking for is something along those sorts of lines, where you've got a high level of reliability, the design decisions have been made, there's enough detail for you to see what's going on, but not so much detail that it basically makes the model unusable. What this means is that when you receive BIM models, the various elements within the model are going to be at different stages of development and different stages of detail. And part of what you have to do is sort out the wheat from the chaff. It's all usable, I mean it's great, but it's the judgment you'll need to apply in pricing these things or rating them up as to whether they're a concept style decision, even though it's drawn in a high level of detail, or whether the specification is actually finalised and you can rely on it. Just quickly, there's often a concern with BIM that it means the designers have to do a lot of extra work, they have to put a lot of information in, or they have to code it for you or do those sorts of things. That's not the case. You don't actually have to ask them to do a lot. A default model still has a lot of usable information for you. There's probably only 3 things, and in fact there's 1 thing per file format. If they're using Revit and they're going to send you a DWFX, they need to set their project units to 3 decimal places. Otherwise, the dimensional data which is generated in the model is rounded off, it's rounded up or down. If you've got a commercial building with thousands of curtain panels, if every curtain panel is rounded up or down, it can make that sort of a difference to the quantity. So you definitely need the project unit set to decimal places. If they're going to send you an IFC, that's fine, but IFCs by default in their current implementation actually don't include quantities. So you might receive an IFC and there's no quantities in it. They need to just tick a box. Export base quantities. If they tick that box, then you get the quantities. For all formats, just ask them to use the area tool to define areas. It's very simple and quick to do, and certainly for early stage cost planning, to actually receive room areas, floor areas is really useful. Otherwise you've got to measure it yourself, which is fine, but if it's coming from the model, it's really helpful. So if they just do those things, that'll really get you off to a good start. Now this particular chart is it's from a company called Gartner in the US. They're a market research company, and this is actually a tool that they use. It's not something I've made up, but I think it relates very well really to the BIM sort of journey that people go on. And certainly BIM, I think, suffers from a lot of inflated expectations, but also unrealistic expectations or simply hype that people have heard. Chances are most people will decide that they need to get on board with it. They'll have all sorts of expectations. When they first try it, when they get the first model, they're going to plummet to the trough of disillusionment because they're going to think, well, what's this all about? It's not what I thought it was at all. There is light at the end of the tunnel. Once you work out, as I say, how to sort the wheat from the chaff, how to actually work with the BIM tools, how to apply the judgment where you need to apply it, which you do need to apply it, then you can move up the slope of enlightenment to the plateau of productivity. Really, I think, having seen Trevor's talk, I think Trevor basically takes us through that path that he's been down over the past couple of years, and he's now going to share with you. So that's the end of my introduction.
Okay, so BIM, excuse me, the good, the bad and the ugly. And really it's to try and give you guys an unblinkered view of what BIM is and what BIM isn't. And it's to give you information that you can go and start talking to architects and engineers and designers and people who create models. As quantity surveyors and estimators, we're not model creators, we're model consumers. And often you're consuming something you haven't cooked or prepared yourself. You can suffer from BIM digestion. So we just start going. I'm a QS by training, graduated in 1991 from DIT in Bolton Street. Worked at QSing on and off for the past 20 years. Got into IT about 10 or 12 years ago doing consultancy work for companies. Working in the BIM space for about the past 4 years. So I'm currently 5D QS on a large semiconductor project in Ireland. and I'm doing lots of consulting with other QS practices in Ireland and getting into the whole BIM space. Quotation here, really this is taken from a publication or a book that was written on computers and quantity surveying. And I'm not going to tell you when it was actually written. We'll come back to it at the very end of the presentation itself. It's very prosaic, the way it's written is a bit strange, and basically this guy reckoned there was a synergy between computer programming and quantity surveying. You needed the same sort of mind. But it's really the last section that we should concentrate on. I hope this is the case because I feel certain that the liaison between the two, which is computers and quantity surveying, will have beneficial results for both, and that these must inevitably be passed on to the client to the ultimate credit of and benefit to the building industry. So just keep that in mind. We'll come back to it at the end. BIM, what is it? Simon touched on what BIM is. To me, BIM, it's a process. It's not a software package. It's not one package. It's not Revit. It's not ArchiCAD. It's not Costex. It's not Vectorworks. It's not Geary Technologies. It's not Navisworks. BIM is people, process, and technology. It's a combination of all three. And the smallest part in the equation is technology. Technology is really only 20% of it. And with a lot of IT projects, you'll find that that metric holds true, that most IT projects that are successfully implemented, it's down to people and process, and the technology is really the small component of it. So it's people, it's technology, and it's process. It's not just one application or one piece of software. Technology is really the enabler. You've all heard the terms 3D, 4D, 5D, 6D, 7D, 8D, and on and on. Some people hate them, some people use them. I tend to use them. I think it tries to explain the whole thing. 3D is actually the design itself or the model itself. It can be created in numerous applications: Autodesk Revit, Graphisoft ArchiCAD, Vectorworks, Bentley, Tekla. There's many more applications. If you're in the MEP space, there's AutoCAD MEP, there's AutoCAD Plant, there's Smart Plant, there's AutoPlant. Hundreds of applications out there that will create models. From a QS or an estimator's perspective, if you happen to have these applications, you can do some scheduling of quantities from them. You can do clash detection. You can do improved visualization. So that's where the models are actually created, numerous applications. As QSs and estimators, we'll be faced with numerous different file formats that we have to work with. 4D is where you combine the model with time and the construction schedule. A couple of applications, a lot of applications in this space as well. Navisworks, Vico, Synchro. And 4D, it's where we take the model, we link it to our construction schedule. So you've got a schedule in Microsoft Project, or you've got it in Primavera, and you want to tie the model to it. You want to look at using the model to see how are we going to build this building. An example, a great example of 4D would be the Leadenhall building, built by Lang O'Rourke, where they used 4D and used simulation to actually build the building virtually 37 times, and in reality build it once. So it's really about simulation, taking your model, looking at how the building will actually be put together, and how it's actually going to be constructed. So it's clash detection, it's simulation. I've also seen it used for forensic delay analysis where projects go bad, but in the BIM world, projects won't go bad. 5D, what we're really focusing on is where we combine the model with costs. Bunch of applications here as well. Costex, Microsoft Excel combined with one of the modeling tools will give you some 5D stuff. Costas, Vico, Autodesk Quantity Takeoff, Solibri Model Checker. I've worked with them all over the years. They have their good and bad points. So 5D is quantity takeoff, but it's also applying costs to it. Okay, so 3D is creation of the model. 4D is combining the model with the schedule and actually virtually constructing the model. And 5D is where costs come into the equation. So what we're sort of focusing on is the 5D aspects of it. You've got 6D, anyone? 7D? I think 6D is sustainability, and 7D I think is life cycle costing, and I think 12D is crime, or there's a mad range of different dimensions that they reckon models can be used or go to. BIM and quantity surveyors. If you Google BIM and quantity surveyors, the first thing you'll find is Dubai Mall. Case study from CCC Construction, huge construction organisation based out of Greece, where this project was built. It was a multi-billion euro project, And the boast is that we eliminated 30 quantity surveyors by bringing in 2 BIM modelers and 2 BIM cost engineers and 8 BIM modelers. It's all bad. Quantity surveyors are redundant, quantity surveyors aren't needed. QS are in fear of BIM, you know, and this guy on LinkedIn will be my nemesis. Architect, super in the BIM space, very good with IFC, but tends to think that QSs will, you know, and can be replaced by software. Rise of the machines, BIM and QSs, are we going to be replaced by PCs and Revit and various other applications? Robert Klaschke, an architect, writing in 2006, nobody wants my quantities, couldn't understand why QSs didn't want the schedules that he could generate from his models. And the perception out there is that we are afraid of BIM. And the reason the perception is abroad is that as a sector of the industry, we just haven't engaged. You go to any of the BIM events, QSs are in the minority. BIM Live show last year in London, Rob Charlton, the organizer of the event, had a slide, 4 quadrants, and the worst sector for adopting BIM were QSs. So the industry is sort of laughing up their sleeve. QS estimators, they're going to be replaced. So this is to try and give you some information to counter the argument that, well, everything is perfect with BIM. If anything, instead of QSs being made redundant, we need even more QSs. Most architects you talk to, they'll say, we've got this magic BIM BQ button. We can push this button and we get a bit of quantities. So you're not needed, you're redundant. You push it, you get instant, accurate, no hassle quantities. That's what most engineers and architects think. They think QSing, forget it. You're on a loser. It's a bit like this guy voting for Christmas, quantity surveyors and BIM. That's the perception. In surveys in the UK here, 14% of BIM users and 27% of non-BIM users felt that BIM made traditional bills of quantities redundant. I think it's far from that. I think the bill of quantities is still a valuable document for cost control and for tendering, whether it's tendering to your supply chain or tendering projects generally. And 77% of Irish QSs didn't agree that BIM makes traditional QS role redundant. I mean, I'd be surprised it wasn't 100%. Generally in Ireland, QSs haven't really engaged either. There seems to be adoption of BIM isn't as widespread as it is in the UK. Industry is aware of it, but haven't really flocked to it. I'm lecturing on a CPD diploma in BIM technologies and DIT at the moment, and last year we had 40 architects on the programme. We had 12 QS and construction managers. This year we've got 32 QS and construction managers and 16 architects. So the worm is turning. The QSs and contractors are starting to wake up to BIM and its opportunities. QS and innovation. How many of you have come across or using BIM or have come across BIM in the wild on projects? Show of hands. Yeah, so it's roughly what it was in Manchester, maybe a little bit higher, and any events I was at in Ireland is probably the same. How many of you are doing on-screen takeoff? Okay, so a few more. How many of you don't do any takeoff? Okay, so, all right. So, as an industry, we're still doing a lot of manual measurement. We're using scale rules and paper drawings. How many of you get quantities or schedules from designers? How many of you would work with guys who make stuff available to you electronically? They'll give you the tonnage of steel or the tonnage of rebar or the volume of concrete in buildings, even as a check. No? Oh, yeah, okay. So there's a couple as well. There's a group called Quantity Takeoff Information Exchange. They're part of the Building Smart Alliance. The Building Smart Alliance have developed this protocol called IFC for sharing building information modelling files. And this group was focusing on quantity takeoff. So they looked at quantity surveying practice worldwide, and they looked at estimators in the States, and through surveys and studies, they reckoned that this was the biggest innovation in 20 years in surveying. Anyone guess what is the biggest innovation in quantity surveying in the past 20 years? No. Right? It's the move from colouring pencils to highlighters. When you think about it, it is. We're Luddites. We really haven't embraced technology. But it was revolutionary. I started off in 1991, set of colouring pencils and a sharpener. And the amount of time spent sharpening pencils to colour up plans was phenomenal. Think of it now. Your output has quadrupled because of a highlighter. Okay? So that's where we're at. We're starting from a low base. We generally haven't embraced technology. Excel, yeah, that's maybe the height of it. So we're not really a very innovative bunch. We tend not to like change, okay? So the move from colouring pencils to highlighters. So it's QTIE. I have a reference in the presentation if you want to check it out later on. Sorry, just down in the bottom right-hand corner, there's a couple of the slide numbers. So if you've got a question related to a particular slide, maybe just take note of it and we can come back and address it. So the good, the bad and the ugly. The team music did play last night, but technical glitches. Any QSs who are nervous, I would say leave now, right? If you want to keep your BIM tinted glasses on. The good from a QS perspective. Clint, counting, again, recounting. If all BIM did was count, if you're an MEP surveyor, if it just counted light fittings or counted elbows or counted T's, that's enough. I've waded through projects in the Middle East where you're in trying to count elbows and T's and bends and light fittings. Horrendous. And the amount of time we waste counting something that can be done automatically is phenomenal, even from 2D drawings. Extracting quantities when they exist in the model and when elements are categorized and labeled correctly. So when BIM works, it works phenomenally well. All right. Visualization, being able to see something in 3D, being able to explain to a junior quantity surveyor or an estimator how something goes together. If they're measuring formwork or measuring any sort of concrete, in situ concrete, just being able to spin something in 3 dimensions or switch stuff on and off and get into the heart of a building itself. You'll notice with a lot of 2D design, architects and engineers never give you a section through a stairs. They never give you a section through a detailed junction or a detailed part of the building or an awkward part of the building. With BIM, there's nowhere to hide for designers. If it's not detailed, you can see it, you can slice it, you can dice it, you can chop it, you can switch stuff on and off. You can really get into the heart of a building or of a model and see what is and what isn't there. So visualization alone is another phenomenal feature of it. Collaboration and agreement. BIM is forcing the industry to change. And I've seen it myself on the course in DIT. The project I currently work on, 13 of my colleagues have signed up to do the course. We work for the client. 6 QSs from the main contractor have signed up to do the course. They're normally at loggerheads. By going through the BIM process, they're actually starting to talk and starting to dialogue an awful lot more. They're starting to agree accounts an awful lot quicker. And you'll see there's a company, QS practice in Australia called Mitchell Brantman, who have a lot of stuff on the website about how BIM has really improved how they can agree accounts and how they can actually get stuff out the door faster by removing a lot of the arguments from the process. A huge feature as well, especially with cost-ex, is automatically detecting and quantifying revisions and model changes. Project I'm working on at the minute, it's gone through 27 different issues of the drawings. And there's guys there doing 2D stuff manually. We're doing the BIM stuff automatically. Phenomenal. To be able to go in and not have to look at a clouded section on a 2D drawing and see what has changed. You know exactly what's changed. The cloud isn't, generally clouding or revisioning isn't very precise. The designers normally don't go back in and edit the CAD drawing, they put a cloud around it, so you don't know. In BIM, they've got to go back in and make the actual change itself. So that's the good. So there's one side of good, there's a couple of sides of bad and 1 or 2 of ugly. But the good, when it's there, is very, very good. The bad, angel eyes. Stuff you'd expect BIM to do, but it doesn't. Not everything is modelled. You're not going to get skirtings and architraves and glazing beads and, gaskets and brackets or fittings with structural steelwork. So depending on the model you're looking at, if you're looking at a designer's model, it's going to give you design quantities. It's not going to have a lot of the detail there. If you're looking at a fabricator's model, yes, you will get the detail. So with a structural steel model from a structural steel designer or structural engineer, you'll get the principal members. You won't get the plates. You're still going to add on your percentage for fittings. But if you've got the detail model from the fabricator, yes, you can get the number of bolts, the size of holes, the number of notches. So depending on who's created the model, you get different levels of detail, different amount of stuff modelled. There's still a lot of 2D details. Typically, with a roof parapet detail, they're not going to model the flashings or the tilting fillets or apron flashings. There is still a lot of 2D stuff in BIM models. All right. Cryptic descriptions, pet hate of mine. You look at the item, you don't see it in the model in context, you're trying to figure out what the hell is it. Severe lack of usable information. So I have a little bit more detail on these in the next couple of slides. This one, different ways of defining and calculating quantities in different design applications. So you look at a model that's been generated in Revit. They might have a different way of defining the length of an object. There's not just one length, there's several lengths. You might have the cut length, you might have a length along baseline, you might have just the regular length. Something designed in Tekla might have a different interpretation of length. You know, it might give you the top and bottom chord lengths, so it's really having to go in and understand what they mean by length or by area. Does the gross area include voids or exclude voids? So it's really different applications have different definitions. Now there is a move to try and standardise that. The same objects modelled in structural and architectural models. So it's an easy one to slip up on, that if you've got a structural model and the structural engineer has modelled all of the load-bearing walls, chances are they're in the architectural model as well. So it's easy to duplicate up on your quantities. So it's just to be aware of it. I mean, it's not something that... Objects not categorised by location or phase on large projects, so where models have taken shortcuts. Uncategorised MEP systems, where everything is lumped in under the same system. Stairs, I thought, super, push a button, it'll give me the volume of concrete. No. T-shaped windows. Now, some of these issues, excuse me, have been fixed in later versions of the software. A project where there was T-shaped windows, it didn't deduct the correct volume or area from the wall that the window was hosted in. Another slide of bad. Wall areas, depending on how the wall joins or how they've modelled it. Wall gables can be an issue with wall gables. Irregular shaped floor slabs can be an issue with irregular shaped floor slabs, but I'll explain these in a little bit more detail. Rebar, haven't seen it in too many models. When it's in models, it's super. You can get the tonnage off the bat, you can get the sizes, you can get the lengths, no problem, but I haven't seen it modelled in too many models, especially not designers' models. Slabs, pads, beams and columns overlapping, where the volumes are a bit askew. Column lengths not transferring, they're in the Revit model, but they don't transfer out into the QS software. Steelwork weights not transferring. So just to explain some of the bad, the perception is that the I in BIM is huge. When I started using BIM first, I thought, great, I've got a database with all of the specification information and all of the material information and all of the quantities in it. But in reality, the information component is quite small. So you're getting the information in there, but often it's cryptic, or there's information in databases that lie outside the BIM that you've got to try and refer to. This is a sample of a schedule taken from Revit, one of the BIM modelling tools. And casework is built-in furnitures and fittings. Anyone guess what that is? It says countertop corner 600 depth, 625 wide, 900 high, and there's a keynote. And the next one is 6 of these Fern classroom wet area classroom, 2,800 wide by 900 high. Anyone guess what it is? Any sort of a wild guess at all? Yeah. Could you price it based on that? So if Robert Klashke gave you his quantities, this is what you would get, right? Could you price it? Cover price? It's a sink unit, 2 sinks, 2 fancy taps, expensive handles, oak doors, okay? So it's just the importance of seeing the item in context. That if an architect says, but I can give you the schedule, I can give you the quantities, don't use them and take them as gospel. You have to see the stuff in context. You have to be able to look at the item and see what does that relate back to. So yes, you can take the schedules, but I would take schedules from designers and use them to check my measure, whether it's a 2D measure or whether it's checking your 3D measure. But certainly don't just take it as gospel from the model itself. Cryptic descriptions. This was a pilot project I worked on last year. This item was called, or was tagged as a roofing accessory. It's a bloody sculpture of a horse. Architect, super architect, but a sculpture of a horse was modelled. And it came in through the software as a roofing accessory. Now, you're pressed for time, you don't go and look, you hide, whatever. Fucking sculpture of a horse. So, is it inflatable? Is it concrete? Is it bronze? Is it paper mache? Suffice to say, he was value engineered out. All right, didn't last too long. So a roofing accessory. So it's a cryptic description. It's not tagged. It's not labelled. If architects are going to do stuff like that, get them to put something in that you can say, well, it's a red flag, it's flag it, that you know to look at it in some bit of detail. This was an example, stairs, spiral stairs, you bring it in, you think, great, I'm going to be able to get the volume of concrete. Look at the properties, there's no volume or surface area. Okay, so you're still trying to figure out the volume of concrete in your spiral stairs. It gives you the number of risers and the width and the waist and various other bits and pieces like that, but you know, in some instances it doesn't give you what you think you will get from it. This was a stadium project I worked on in the Middle East. Huge stadium project, a 50,000 seater stadium with a few other bits and pieces. The issue we had with this was what I've done, I've just made the basement slab translucent, and it's sort of this colour here. The slab ran up to the top of the slabs. The slab ran up to the top of the pads, and the pads, this red area here should have been deducted out of the slab. But what we got was a 300 mil overlap between the slab and pads. It was about 3,300 cubic metres of over measure. Okay. The only reason we caught that was that we previously done an exercise on this in 2D, and we had the quantities, and we could say, yeah, there's an issue with the quantities. It's gone up by 3,300 cubic metres. We were way down the food chain. We were sub consultants. We had the model sort of unofficially, so we couldn't go back and query it from the contractor or from the designers. But we couldn't ask to see the model in its native format. We had it in a format called DWFX. But we picked it up, we used our judgment, we figured out there was an issue with it. It didn't tally. You know, visually we saw it. Uncategorized MEP systems. This is the same stadium project. There was 36 kilometres of pipework. 16 kilometres was classed as hydronic supplier return. That's all it said. It told us the material, told us the size, but they were all classed as hydronic supplier return. We were producing a cost plan. So we needed to know, is it chilled water? Is it hot and cold water services? You know, is it drainage? So it was a simple matter for the engineers to go and tag stuff as they actually model it. For us, we had to go and switch stuff on and off and try and isolate items and try and see, well, what's it connected to? Is it connected to an air handling unit or a fan coil unit, or is it connected to a toilet? So small things. I mean, it was super with the ductwork. To be able to go and measure the ductwork on that stadium in half a day was phenomenal. But we had some small issues with it we had to go and try and figure out, and the amount of ductwork in it was just ridiculous. You know. Missing MEP quantities. This was a piece of ductwork from the model itself. It told us the number of these bends, and we were doing the ductwork by square metre. Didn't actually give us the area of ductwork in the bend itself, so you were going back to try and come up with an approximate measure of ductwork for the bend. So small things that can cause some annoyances, but the engineer, if he pushed his button, he still wasn't going to get the proper quantities out of the model itself. So if architects and engineers say, we'll push the button, tell them to go ahead and see what sort of quantities they want to get out of the model itself. The ugly. Poor and lazy modelling, where architects model and take shortcuts and don't use the tools as they're designed to be used. Where they need something like that horse. They do a 3D solid or a morph or a transform. They don't give it any quantum or any description. Even if a designer is doing something that isn't in their standard family of objects, let them tag it. Because the way a lot of the modelling software works, the architect or engineer, unlike AutoCAD where they're going in, or CAD where they're drawing a line or drawing two parallel lines and saying, right, that's a duct, and they're putting a text label on it and they're giving it a size. They're saying that it's 400 by 200 duct. BIM is based over libraries of objects, libraries of parametric objects. So the architect will go, or the engineer will go to his toolbar at the top and will say, I'm modelling walls. And he click a drop-down arrow and he will get a list of the walls that he has in his library. And he picks a particular wall, he clicks the start point, he clicks the end point, and he's already set the height. So he's pulling objects from a standard library. In some instances, the objects don't exist in the library. Maybe it's a custom fitting, or it's a countertop, or it's something. And they'll use a 3D modelling tool to just model it, even if they just give it a label or give it some sort of description. Bad quantities, where the quantities that come out of the model are wrong. We had an issue on the stadium project with the steelwork weights, where they were half what they should have been. But we figured out what had actually happened. You still need to do your checks. You still need to use your judgment as a QS to validate. What had happened with the steelwork model, we think, was that the engineers modelled in whatever application, they sent it to a structural analysis package for analysis, they brought it back into the original modelling application, and it lost whatever properties. Most of the QS software, it's not measurement software, it's not going in with BIM, the software isn't physically going in and getting the coordinates and saying, right, the start point on this is X, Y, and Z, and the end point is X, Y, and Z. It's not measuring. It's taking properties that are attached to the objects that were originally attached in the BIM software. So in Revit, the area of a wall will be transferred across as a property. So most of the QS software isn't actually going in and measuring. It's not calculating. It's using properties that exist in the model that were created in the original design software itself. This IFC format, earlier on we mentioned that there was a bunch of different design applications. They all have different file formats. So to work around the interoperability issue, there's a format called Industry Foundation Classes. Some software implements it and uses it very well. Some software uses it very badly. It is changing. A lot of the vendors are now starting to take IFC seriously. And I think a lot of it was down to the UK government telling them that they had to sort the issue out or they would bring in third parties to do it. The ugly, the poor and lazy modelling. Oh yeah, this was this pilot project I worked on last year. This is a small community centre that was being refurbished. And the architect, when he modelled a lot of the roads around the building itself. When he was modelling, he didn't set the bottom plane correctly for the roads. He should have probably set it at 400 or 500 mil, but it went to whatever number of metres. This was all hidden. So you'd have a layer there, which is your topography. So unless you get in and you switch stuff on and off, you won't see it. So if the architect had gone and pushed his button, he would have gotten... Oh yeah, and on this project, if the engineer was a big advocate for lean construction. It was more lean mix construction. There was something like 81,000 cubes of concrete and 165,000 cubes of concrete in these structures here. About 14 million and about 94,000 tonnes of carbon. So it was just an illustration to show the architect, well look, if you push the button and you got your schedules, this is what you would have gotten. So QSs are needed to validate. Poor lazy modelling. This is a refurbishment project. The architect had decided to put on these external balconies. Didn't obviously have balconies or have these objects in his library of objects. He modelled them as a mass. So we got no information from that. It told me that it was a walkway, columns 1, family name was walkway, columns 10, and that was it. It gave me a count. So I knew there was 20 of those. So I would still have to go back in and do a manual measure on that. All right. So that's where if the guy had modelled it in a fashion that, well, we could have gotten the tonnage of steel from it. So really, that was worthless to a QS or to an estimator. It wasn't going to improve my process. It wasn't going to make it any quicker. This was another example of a project I'm currently working on. I think it's 500 mil diameter chilled water pipework. This object here, when we imported through Costex, it was modelled as a 3D solid. No other information. No data about the object itself. We have a QS I work with who's phenomenal. MEP QS or mechanical QS, process QS. He reviewed it. He reckoned something was wrong. We thought maybe it's a gasket or maybe it's a flange or something, it's not expensive. He said, no, that's a valve. He checked the P&ID and it showed us a check valve, which was worth about £4,000. So there was 15 or 16 of these on the particular system. So it was a big miss. So the P&ID hadn't been updated or the model hadn't been updated or someone took a shortcut and it went in as a 3D solid. So it was a valve that didn't exist in their library, so they just modelled it as a 3D solid. The same engineer, I gave him a 12,000 line extract from Costex of MEP stuff, and within 5 minutes he could come back to me and say, the model is wrong. They're labelling this as a particular system, a scrubbed exhaust system. It should be Teflon coated ductwork, they've put it in as galvanised steel. So engineer or architect pushed the button, would have gotten quantities, would have been wrong, horribly wrong, several £1 million wrong. So QSs, estimators, we need to validate. There's still a vital role for QSs with BIM. And this was just a quick run through those problems and what the root cause of the problems. You can see most of the problems were caused by people and how they've used the software, how they've used the design software. So it's all down to architects and engineers making mistakes. Well, not making mistakes, but down to them not seeing our requirements or modelling in a particular way. Because a lot of engineers, well, ultimately it's our fault. Because we haven't engaged with QSs, or as our QSs, with architects and engineers, giving them feedback. We haven't told them, well, look, we're not using BIM, so we don't know. We can't give them the information. They don't know their model is unpalatable to a QS or to an estimator. So most of the issues are with people. Some of them are with process, and some of them are with software. The software stuff is improving. I mean, since I went through that list, this has changed. This will change, you know, and this was down to just the fact that the stuff was round-tripped. So most of the stuff there is fixable. It just needs a QS to get involved and start talking to designers. After all, you're thinking, geez, why would we bother? What's the point? This is the traditional approach to design. Architect would normally throw a set of plans over the wall to the structural engineer, who'll throw them over the wall to the services engineer, who'll throw them over the wall to the poor QS at the end of the chain. And we cost a completed design. So we're costing a completed design. We're not helping the architect design to cost. So we're failing in that we're not giving them information at an early enough stage, quick enough, to help them to influence their design. We need to be able to help them design to cost. So we want to provide cost information when it can be used to influence the design itself. And just in terms of automation, easy takeoff, 2D paper-based is going to be the slowest process you can do. Raster PDFs, a bit faster, and ultimately a BIM model is going to give us the fastest quantity extraction of everything. Someone doing stuff on paper versus the BIM model wins hands down. But it's crap in, crap out. I think what we have to offer as an industry, just want to check my time here. The traditional 2D design process, we'd normally start designing and this might be at 30%. We'll have a value engineering exercise and a lot of design will have been wasted. We're going back to redesign. We start designing again, we get to 60%, maybe there's another value engineering exercise. Process starts again, there's design has to be redone because we're over budget. We start again. So there's an awful lot of design time wasted and value engineering exercises done which breed resentment on projects because ultimately it's the quality of the finished product that suffers. It's normally the finishes that suffer. As QSs, we have to start offering concurrent costing, where on a weekly basis or fortnightly or monthly basis, we can put the model through a quantity extraction process and we can run some costs against it and produce a cost report or a cost check on a much more frequent basis and influence the design that instead of them going off and doing a huge amount of design and wasting resources, it's controlled on a quicker basis. Anyone working on design and build or in a JV, if you can offer this to your contractor or to your client, phenomenal. You can get a much, much tighter control on your costs at an earlier stage in the project. There's more than 300, this QTIE, the crowd that came up with the idea of us innovating with highlighters, they reckon there's more than 300 individual cost estimates made of a building during the project. So the QS will measure, the contractor will measure, the subcontractors will measure. Projects I'm currently working on, the one set of items, even with BIM, we're measuring it 6 times. We're measuring, the contractor's measuring, the subcontractors are measuring, the design team are measuring. And I'm trying to convince them, guys, in BIM, the quantity is the quantity. 75% of the time taken during these estimates is just counting stuff. So a lot of our time as QS is wasted just counting stuff. We're not adding any value. Skanska deployed BIM tools and cut takeoff time by 50%. Projects I'm currently working on, and the figures are astounding. Mechanical and process, we looked at the numbers, I think it was last week, and on one particular part of the project, and the project we're working on is a €2 billion project. 67, the output per 2D QS day, in terms of what they were measuring, was roughly £67,000 worth of measure. BIM, about 1.7 million per QS day, per 5D QS day. So hands down, in terms of measurement of quantity extraction, BIM wins. You know, I think the guys were shocked when they actually saw that. I mean, we did 30 million euros worth of scope, I think it was in 5 days, myself and another guy. You know, so it just, doesn't make sense to do stuff in 2D when it exists in 3D. And it will facilitate design to cost versus costing a finished design. For estimators, it allows you price the how, not the what. It allows you to look at location-based quantities. Excuse me. As quantity surveyors, generally we'll measure in 2D, we'll measure by floor or by plan. But we compress it all down into a bill of quantities, and as an estimator, you get one line that tells you you need 200 tons of steel beams, or you need 300 tons of steel beams. You don't know where you need it. You're applying a rate across the board to your structural steel. Maybe you're applying steel up on roof level, and the particular week you're installing it, your tower crane is busy, you've got to bring in a mobile crane, and it's costing you £5,000 a tonne, versus placing structural steel at ground floor from a teleporter, it's costing you £1,500 a tonne. So to me, you get a bill of quantities as an estimator, you get the model, you still run your own quantities, you produce location-based quantities, you become more strategic in your estimating or pricing. You know, you look at where the actual work is in the building itself, and you change your rates to suit that. How will the work be done? What are the health and safety implications? What are the costs? I think what it's going to mean for QSs is we'll do less work at tender stage preparing the BQ, but we'll do more work at earlier stages extracting quantities and designing and costing design options. So there'll be less work but more often. So architects and engineers say, yeah, but it's easy for you guys. Well, we're just going to do less work, but we'll be doing less work more often. It's going to balance out. And it's not going to give us a huge amount more time. And we're going to be adding more value. Designers can design quicker and they can iterate through designs faster. So they're going to have a huge amount more options that they want cost checks done on. We'll need to keep up. We probably have to start looking at producing carbon estimates. The UK government BIM mandate, they've mandated that they're looking for a 20% reduction in cost, and they're looking for a 27% reduction in carbon. Who's measuring the carbon reduction? So it's an area that QSs can easily start producing carbon estimates. Mitchell Brantman in Australia talk about a living cost plan that changes as the building evolves, and they talk about having two columns, a cash column and a carbon column. And we can do it very easily from BIM models themselves. Good BIM, it means less work but more often. Bad BIM is more work more often, and ugly BIM is just purely bad work. All right. How do you make it work as a QS? You have to understand what BIM quantities are. Designers, building information models will generate design quantities. They're not construction quantities. So they're quantities, it's what's in the finished product, not actually what's gone into the product itself. We discussed 2D details earlier on. We discussed not everything was modelled. In terms of quantities, you've got three types of quantities. You've got quantities which are based on model items. So they're actually in the model, they're physically modelled. The number of doors, the volume of concrete and columns. Quantities derived from model items. It might be architrave around doors or skirtings. We can calculate those based on objects that exist in the model. It might be formwork for columns. We can actually calculate the formwork required for a column from an object in the model. But we'll also have non-model quantities. Stuff we have to go back to measure from 2D. Construction joints and concrete slabs, shoring, pinning, items that designers normally wouldn't design, wouldn't be concerned about. All right. So three types of quantities: model-based, model-derived, and non-model. Excuse me, I wouldn't decommission the scale rule just yet. All right. Maybe it'll be an electronic scale rule. You know, I would be advocating moving to on-screen takeoff. And just illustrate it, from the concrete model, we can get, from the model, in the model itself, we can get the rebar, the concrete, and the formwork. We can derive some quantities from the model. How do you overcome bad and ugly BIM? It's all about validation. Validate, validate, validate. Talk to designers. Talk to them at the start of the process, during the process, after the process. Give them feedback. Tell them what does and doesn't work. There should be a document called a BIM execution plan on the project. A BIM execution plan just sets out who does what, when, what software they're using. So if you look at the BIM execution plan, you should be able to see, well, they're designing in this, they're sending it out to this, they're bringing it back in. So it should raise some flags. It should tell you about software versions. So I would look for a BIM execution plan if one exists on the project. Ascertain if the designers are exporting models for analysis, okay, as we discussed earlier on. You have to figure out what's in the model, what has been modelled, but more importantly, what's not in the model. Is there a gap in the scope? Is there stuff on 2D drawings, or is there stuff on a civil engineer's survey plan? Not everything will be modelled, so you have to try and figure out what's not in the model and how do you measure it, how do you account for it. Excuse me. You need to improve the good, Fix the bad and eliminate the ugly. This didn't get a reaction last night at all. It probably is derogatory, but I think QS is essentially what we will be building information ferrets. Trying to figure out what is missing from the model, or what the hell are objects in the model. I spend a lot of my time scratching my head thinking, what is this object? Or else we're BIM detectives. Now he's still smiling, so he's only new to the job. You know. So a lot of your time is going to be spent validating and checking, and using your professional judgment to look at a model and see what is it good, is it bad. 2 years ago, 2012, the RICS BIM conference, a speaker from the John Lewis and Waitrose gave a talk, and they've been using BIM on a lot of their projects, and he said, look, we're not paying QSs from the shoulders down anymore. We're paying them from the shoulders up. We're not paying them to measure and count. We're paying them to use their commercial judgment, to use their knowledge of procurement, to use their knowledge of construction, to validate what's actually in the model. So it is all about judgment and validation. Yeah, we get the quantities, but we have to validate them. The industry, or what the perception is, that there's one single model with everything in that one single model. There isn't one single model. To me, that's Nirvana BIM. Maybe it's level 3 BIM, where it's all integrated. It's what the vendors tell you when you look at vendors' presentations. This is what's actually out there. Multiple models with multiple file exchanges. And level 2 BIM mandates and tells you how the file exchanges are done and how often you exchange, and there's a protocol called PAS 1192 which governs how stuff is exchanged. But there'll be multiple models. There'll be MEP models, there'll be structural models, there'll be architects models, there'll be cladding or special subcontractors models. More models, more risk. You could have stuff, the curtain walling could be in the architectural model as well. So you just have to know, look, validate, decide what protocol you're going to follow, come up with a risk register. In the wild, there's a lot of talk about 2D BIM or level 2 BIM, and at the last RICS conference it was all level 2 BIM. If you're on a level 2 BIM project, this is what you need to do. A lot of you aren't going to encounter level 2 BIM. It's 21 months until the government mandate kicks in. A lot of you will just work on projects where it's lonely BIM, where the client hasn't mandated it, but the designers are savvy and they want competitive advantage, and they're using BIM tools to actually produce a coordinated set of documentation. Because the beauty from a designer's perspective is they can model it in 3D. From the model, they produce all of their sections, all of their plans, all of their elevations, all of their schedules. If they decide, the client decides, I don't want that door in that location, the architect deletes the door. The door disappears in the model. It disappears in the plans. It disappears in the sections. It disappears in the elevations. It disappears out of the door schedule. And if the client changes his mind, you can press Control Z and you can bring it back in again. So it gives the architects and engineers a coordinated set of documentation. And a lot of architects who are using it for competitive advantage gains themselves. The designers using it of their own accord. It isn't a project deliverable. It's usually a single model. Collaborative BIM is where the client has mandated. You've got a number of designers using it. It might be a project deliverable. There'll be multiple models, possibly multiple formats, more headaches. And just quickly to run through BIM workflows. MEP workflows. The first thing, I'd review the BIM execution plan, what is and what isn't modelled. I try and find out what role do the single line diagrams, process flow diagrams, P&IDs play. Will you still need to measure scope from P&IDs? Is there stuff on the P&IDs or on the schematics that isn't actually in the model? Okay, vital with MEP projects. Validate, use the schematics. Chances are with electrical stuff, cable won't be modelled. You'll still be going back to a cable schedule to actually take quantities from that. The panels, the containment, chances are will be modelled. Review and check systems against what's modelled in the BIM. So you'll use your P&IDs and you'll use the 2D stuff to validate what's in the 3D. If the project changes, will the schematics change if the model changes and vice versa? Does the model you does the model allow you to measure in accordance with rules of measurement? Okay, so if you're using CIMIC to measure MEP stuff, normally you measure true fittings in CIMIC, and the fittings would be extra over. So if you're using an agreed schedule of rates with a contractor, do you need to adjust your schedule of rates? Because BIM will measure fitting to fitting, it doesn't measure true fittings. Okay. So you need to just look at the rules of measurement and see how can you amend either what you're measuring, or how can you amend your schedule of rates to account for these particular issues. For CSA, Civil Structural Architectural, review the BIM execution plan, validate, review 2D details. Is there 2D scope? What's the demarcation between 2D and 3D? Come up with a BIM risk register. Anything you think that is a risk or there is a potential of over-measuring, under-measuring, identify it. Come up with a plan how you're going to deal with it, but document it. And I think you need to measure in a tool that will allow you to combine 2D and 3D measures. Some applications will let you do 2D or 3D. Very few of them will let you do 2D and 3D, but you need a tool that can do both. Are the civils or groundworks 2D? Because BIM isn't just building, it also applies to infrastructural. You know, there's a big move to get infrastructural projects into the whole BIM space as well. And a lot of the civil stuff has been done in 3D for years. Okay, a lot of the alignments for light rail and for roads were all done in MOS or MX Rail or MX Road going back 20 years, 30 years. The traditional workflow, we take our 2D drawings, we take the rules of measurement, this is the Irish rules of measurement. Essentially what we're doing, we're taking the plans, we're taking the rules of measurement specification, we're creating construction recipes. We're applying those to quantities that come out of the model, and we're eventually attaching our unit costs to it, and we're coming up with a cost plan or our estimate. So we're combining, we're reading the rules of measurement, we're reading the specification, and we're creating construction quantities. The model will give you design quantities, but we put the intelligence on it. We apply these things to it. The BIM workflow, essentially, it's the same process. The only thing that's changed is our quantities have been generated from the model. We're not actually generating the quantities. We're taking the design quantities and we're attaching the rules of measurement and specification to them. We're creating construction recipes. We apply our unit costs and we produce our estimate or a cost plan or a BQ. So essentially, the process to this stage differs. And I think what I've found over the past couple of years is I'm not doing a 2D or a 3D, it's a hybrid. I'm having to work with 2D and work with 3D. Apply the rules of measurement, read the specification, create my construction recipes, create my construction quantities and create my bill of quantities or my estimate. So really, this is all quantity agnostic. It doesn't care whether they come in from 2D or 3D. So essentially, below the line, it's going to be the same or similar type of process. The key is having a tool that will let you do 2D and 3D. 2D and BIM, pure BIM. You'll have designers only doing 2D, you'll have some doing 3D, some doing paper. And this is just some technical stuff on the BIM side of things. Big issue we'll face as quantity surveyors is designers using different models. We need to be able to work with multiple different models. So we need a common format to get information from design applications into measurement and estimating applications. And the formats that I've worked with over the past couple of years, there's a format called DWFX, which is like a PDF. Sorry, it's from Autodesk, but it's for exchanging information similar to a PDF. You will see some 3D PDFs and Bentley iModels out there as well. All of these applications all use their own proprietary file formats. No application I've come across can read a native Vectorworks file, a native Tekla file, a Bentley file. So you're looking for something to get information from all these formats. Chances are it's either IFC or iModel or 3D PDF. From Revit, you'll come into a DWFX file. You may get some stuff in Navisworks, which you can route into Costex using a plugin. So Costex is probably the only application I've seen that can handle multiple formats. A lot of the applications will handle IFC only or DWFX only, or they might handle 3D PDFs. So Costex, I've used a lot of the other applications, but it's the one that's worked for me using all those formats. And I think I've used all those formats apart from my model in the past 12 months. My BIM toolbox, my data extraction tool. So to me, Costex is a data extraction tool. It's taking information out of the model, is Costex. Like essentially, it's my QS Swiss Army knife. I use it for interrogating the models, for visualizing the models, for extracting information from the models, for putting my own QS information back up to the objects in the model or attaching information to the objects in the model. BIM investigation tools, I use Navisworks Manage, I use Solibri Model Checker, and these are all free tools. So tonight, when you leave here or tomorrow, download Autodesk Design Review, download Tekla BIM Site. This will do IFC files, this will do DWFX files, and just having a look at models, and there's sample models up there on the websites. Just to get yourself into that space, Design Review will allow you to view 2D PDFs. will allow you to view 2D DWF files, will allow you to do some very basic redlining and measuring on screen. It won't allow you to export the measurements, but you know, have a look at those free tools if you're getting into the BIM space. Have a look at some sample models. Microsoft Excel, Microsoft Access, I constantly work with cost-ex and exporting stuff to Excel and bringing it back in again, you know, and doing filtering and sorting and that stuff in Excel. And I would say, I'll just flick through this one. If you're having a conversation with an architect or an engineer, you know, no 3D solids or in-place masses. If you're using them, label them. Create a simple BIM execution plan if one doesn't exist. Tell us ask them have models been sent out to analysis packages and back in again. Tag your systems. Share the model in its native format. Often architects and engineers won't give you the model in its native format. Chances are you won't have a copy of Revit or ArchiCAD or Tekla, but if you have a copy, I would always ask them for a copy of the Revit model. Often they won't share it because of IP, intellectual property concerns, that most applications now, BIM applications, come with some very, very basic libraries of objects. So a lot of architects would have gone and built up their own libraries themselves. And they would have gone in and modelled up the doors and put them into the library. So they've invested a lot of time in it and they don't really want to share them. But what is happening is that a lot of manufacturers are starting to manufacture libraries for Revit. And if you go to the National BIM Library affiliated with the NBS, there's libraries there of objects which have all of the manufacturer's information and all of the parametric information and all of the coding and good quality descriptions. That's starting to happen an awful lot more. And you will see the information coefficient in models standardizing as architects start using these objects. Get them to model by floor or export the model out to you by floor. I would always take a set of 2D plans from the models as well. And I think we have to offer return on the designer's BIM sweat. We have to give them faster estimates and faster cost checks. And I think BIM really is a great opportunity for QSs to offer more services. We can get into life cycle costing. When I left college in 1991, we were meant to be doing life cycle costing, and hasn't happened. We haven't gotten into that space. Now we can get into that space and start producing stuff. Carbon costing is a huge area. Living cost plans, waste management for contractors, waste management plans, coordination, constructability, clash detection. QSs can possibly look at doing this, offering this service to contractors. Model validation and verification services. And there's major synergies with lean construction. I think technological problems are temporary and can be bypassed by process and people. So any technical problems I've faced over the past couple of years, generally we've managed to work around them somehow. Might have been very frustrating, you're climbing the peak and you're in the trough again, but we've normally gotten around them somehow. But it's having something flexible to do it. You need to engage with BIM users and promoters and just counter the myth that we're afraid of BIM. I mean, I'm not afraid of BIM, I'm afraid of bad BIM. And the only way that will change is if we get in and start talking to people. If we're to look at quantity surveying and estimating its construction equipment, traditional takeoff is a lump hammer and a coal chisel. So you're going demolishing a wall or you're demolishing a building. It's going to be slow. Anyone can use it. You don't need much training. It's hard work. If we look at on-screen takeoff, it's like having a Kango hammer. You need a little bit more training, a little bit of safety equipment, but you can certainly be a lot more productive. BIM takeoff, which is what I've been doing a lot of, is like using a jackhammer and a compressor. Certainly get through it a lot faster. It can be backbreaking at times. You need a lot more training. But what I'm trying to get to with my current client on the current project is BIM Plus, where we're using a rock breaker to knock down that building. This is where we're taking the model and we're applying quantities automatically. So to me, that's really where we should be trying to get to as QSs and contractors. It's BIM Plus. It's not just being happy with BIM takeoff or on-screen takeoff. This is what it says in the BIM tin. This is the standard box of biscuits you get in Ireland at Christmas. USA biscuits. It says on the tin, they're push button, no effort, accurate, instant quantities. When you open the tin, you're getting cream crackers at the minute. All right? They're unpalatable without a topping. But I think what can be in the tin are chocolate biscuits. All right? And finally, the last slide, you'll be relieved to hear. The quote we had earlier on. Anyone guess what era where that quote came from, or what year, or what decade even?
70s. George Washington.
Oh, not far off. It's from Quantity Surveying by Computer by Colin Dent. Colin Dent actually lectured Simon, he was telling me last night. So. It was published in 1963. Now you want to see the photographs in that book of QSs standing around this big machine looking on in amazement. And I came across it in this practice, Austin Reddy and Company, they're an old practice established in the 60s in Dublin, and they bought it in 1965. They bought Costex in 2012, December 2012. So you guys haven't got 50 years or 60 years to make up your mind. You've got 21 months. So I would jump into the BIM space now. You know, hopefully we haven't frightened you off too much, but you know. And any questions and contact details if you need any consultancy stuff done, the 5D stuff, drop us a line and we'd be happy to help you.